So, on Tuesday, we started the gas laws, and I introduced gas laws by showing you a picture of me scuba diving. So, that was to introduce, help y'all understand. So, the whole point of Tuesday was to help you conceptualize Boyle's law, help you to conceptually understand how different variables are related to each other, especially pressure and volume. Now, after y'all went in the back and you had your challenge where you had to make the diver go down to the bottom of the sea, I then had y'all come back up front. We looked on the back of the periodic table and we looked specifically at this particular formula. Tell me, what is important about that formula, Bailey? Hmm? Mm-hmm. Combined gas law. What's important about that formula? You don't know? It is different than the other ones. Why did I spend so much time talking about that formula on Tuesday? You can use it to make different formulas. In fact, in the past, I used to write all the formulas on the board, and you're only allowed to use the periodic table on the test. And so I didn't give students a chance to, in their mind, realize that all of these formulas are derived directly from the combined gas law. So you can create all three of those formulas from combined gas law. So for example, Boyle's law, volume times pressure. That is the formula you use in a particular problem if temperature is held constant. So you can hold different variables constant, and that's how these other gas laws are derived. So the next thing we talked about are the different variables. So volume. You can and will, probably a better way to say, you will be given volume most likely in milliliters or liters. And pressure is going to be in one of these for, oops. So pressure is going to be one of these four units. So ATM, kPa, mmHg, or torr. All right. And you are going to have to know how to convert from one to the other. So I'll show you how to do that in just a minute. But one conversion that I did already show you was the degrees Celsius to Kelvin. So if you're given degrees Celsius, all you do is add 273 to convert to Kelvin. Okay? So let's look at problem number 1. I need a volunteer. Tomas. All right, Thomas. Come. You don't need Smith. Just read number 1. Yeah, come on. Well,
Can you hear me? Yeah. The pressure on a 30.9. The pressure on a 30.9 milliliter sample of oxygen at 702. What is that? Capital HG. You made a mistake by calling. Is changed to STP. Is changed to STP. What is the new volume?
Very good. Thank you. So, we have volume and pressure changing here. So, eyeliner is stinging my eye now. So V1 times P1 is equal to V2 times P2, okay? Oh boy. Fun times in chemistry today. Alright, hold on. Let's pause this again. V1 times P1 is equal to V2 times P2. So, V1, 30.9 milliliters. P1, 702 mmHg is changed to STP. What is STP? STP is standard temperature and pressure. So if I just said, what's standard temperature? You would say 273 Kelvin. So 273 Kelvin. Kelvin is a unit of temperature, and that is standard temperature. Standard pressure, 1 atm is standard pressure. However, atm is 1 unit. I could also say standard pressure is 101.325 kPa because look, 1 atm is equal to 101.325 kPa. Or I could say standard pressure is 760 mmHg or 760 torr, which is really the exact same conversion. Now, standard pressure is any one of these units. And you'll see in a minute why you would want to pick one over the other. You'll also use all of these if you need to do any conversions, which you will definitely see that very soon. Okay, so standard pressure. The key to working these out, whatever unit you have on the left has to equal the unit on the right. So V1 is 30.9. We'll plug that in. P1 is 702 in mmHg. We don't know what V2 is. That's what we're solving for. And P2 is standard pressure. What's standard pressure in mmHg? 760. Good. Okay, so if we solve for V2, divide 760 over, you should get 28.54. How do y'all feel about number 1? I'm going to skip number 2 and number 3. Those are the harder ones I'm going to save for last. All right, let's go to number 4. So in number 4, a gas at negative 12 degrees Celsius is heated to 16.8 degrees Celsius. If the initial volume is 216, what is the volume changed to? So we have temperature and volume. Temperature and volume. So that's going to be Charles' law, which looks like this. V1 over, whoops, V1 over T1 is equal to V2 over T2. Now I have to change temperature to Kelvin, add 273. And when I do that, that gives me 261. When I add 273 to 16.8, that gives me 289.8 Kelvin. And that's all the conversions I have to do for that one. So now I'm just ready to plug everything in. 216 over 261 is equal to V2 over 289.8. So you can cross multiply on that one, and that would be fine. And when you do solve for V2 via cross multiplication, you should get 239.83. Any questions? Number 5. Absolutely.
Teachers, please excuse the interruption.
Number 5.
The pressure on a 90.3 milliliter sample of oxygen at 502 mm capital HG is raised to a standard pressure. What is the new volume?
Good. You ready to solve it now?
That's right. That's right.
All right, so number 5. What 2 variables do we have in number 5? 90.3, so that's volume. And mmHg is the unit for pressure. Good. So VP, I don't see anything else changing. I don't see temperature in here, so I know temperature is not even involved. So there's only one formula that involves changing volume and pressure, and that's Boyle's law. So that's the one that I'm going to use here. So you really have to read these. You don't know which gas law to use in the beginning. You have to read the problem in order to know which one to pick. Now, pressure. I start at 502 mmHg. That's raised to standard pressure. What's standard pressure in mmHg? Perfect, 760. So now I'm ready to plug everything in. So volume is 90.3. P1's 502. V2, and then 760. So plug that in, and you get 59.65. So y'all plugging this in your calculator just to make sure you know how to solve it. All right, number 6. The gas is at 5.72 atm, 82 degrees Celsius. The pressure is changed to 2954 torr. What is the new temperature? Okay, so what 2 variables are being changed here? Pressure and temperature. Good. So that corresponds to pressure, temperature, Gay-Lussac's law. All right, so temperature, I know has to go to Kelvin. So add 273 to 82 and you get 355 Kelvin. And we're looking for the new temperature. Now the pressure is what's going to hold us up a little bit, because remember, the unit on the left must be equal to the unit on the right. We start with ATM, but we're given final pressure in torr. So what do I have to do? I'm going to have to convert one to the other. It really doesn't matter if I convert them both to ATM or both to torr. So on my paper, I just chose both of them to be in ATM. But like I said, if you want to do the opposite, we'll see if we get the same answer. So 2954 torr. And Sterling, you said how many torr is equal to 1 ATM? Perfect. Notice how I put it on the bottom. just like any other conversion would be. So 2954 divided by 760 is 3.89. So now I'm ready to set this up. You don't have to write out your formula, but it's just easy to see where to put everything. So 5.72 is P1, T1, 355. P2 is 3.89. T2 is what we're looking for. So if you know how to set it up, good. That's skill 1. Skill number 2 is, can you plug it in your calculator and solve? You just cross multiply. And when you do that, you should get to 41.42 Kelvin. Four two. Questions? Okay, we're going to go to the hard one now. All right, everybody brace yourselves. Take a deep breath. And when you exhale, let all the stress out. When you breathe in energy, focus, mental focus, perseverance, patience. And when you exhale, exhale all the stress. Y'all feel the stress just coming off of your body? I do. So number 2. Number 2, you have to use the combined gas law. That's the one that has 8 different variables in it. Now, what makes the combined gas law one of the hardest ones is you have to do the most conversions. Typically, you have to convert the temperature to Kelvin, and then most likely the pressures are going to be in different units, so you got to convert one to the other. Your volumes are typically fine, but then once you do all that and then you plug in your numbers into the formula, you then have to solve for it. Do you have a question? You're just stretching. All right. So let's go ahead and do that. Notice my volume is in liters, and that's fine as long as the end volume is in liters. So it just has to match up. My temperature 23 in Kelvin is 296. And then 10 plus 273 is 283. So we're almost there. We've got our volume, we have our temperature. Now we just got to make sure the pressure is going to be the same. So I have kPa here, and I need torr. So that's a problem. But what we can do is just go ahead and convert kPa to torr in the beginning. So if I start off with kPa, what do I put on the bottom? kPa, which is 101.325. And then on the top, I put 760. And when I do that, I should get 6158. All right, we're ready to plug everything in now. Get your calculators ready. So it's going to be a doozy. So 23 times 6158 over 296 is equal to 7.43 times P2 over 283. All right, if you don't even know where to start, I'm going to help you. If you don't have in your calculator this number, you need to get it in your calculator. And how you get it in your calculator is go ahead and plug in 821 times 760 equals divided by 101.325 equals. And that way you have this number, but there's also some decimals, I think, that come after that. So we're going to include that in our calculation down here. So then take that number that's in your calculator, multiply it by 23 equals divided by 296 equals. So at this point, we have simplified this whole part. So we're trying to get what P2 equals. So I'm going to have to divide that part over. So press the division sign, open parentheses, 7.43 divided by 283, close parentheses, equals. Did you get a big number? 18,000? Good. 18,225.274. All right, number 3 is also a combined gas law question, and I want you to do that problem. That's the one problem you're going to do in class. And while you're working on that, I'm going to go ahead and pause the video. All right, here we go. Number 3, so 97.5 milliliters. We're looking for the new volume. That'll be in milliliters. Temperature, it's got to be in Kelvin. So that you should have gotten 249 Kelvin. And this one should have been 276.7. I chose to convert both of my pressures to kPa. And if you did that, this one should have been 222.92. If you converted both to ATM, that's fine. You should have still get the right answer. So now I can plug everything in. And solve. And y'all can do the same method for this. Plug in 97.5 times 27.5 equals, divided by 249 equals, divided by open parentheses, 222.92 divided by 276.7 close parentheses equals. Okay? Oh, and the final answer, 13.37 mils. And that's it. Anybody want to have any last minute comments before we go off the air? Thomas? Thomas? He said sayonara. Say it.
This is Thomas Garner signing off.